Hi, hello, welcome back to our channel. Today we are going to discuss about very interesting and easy topic, and it is important for final exams for both AP and TS state. Those are the S.a.qs from the laws of motion. So in this chapter we are concentrating on the force. Our first short answer question is, one stone is there. The mass of the stone is, they have mentioned 0.1 kg. So when the stone is throwing upwards or throwing downwards, and when it is at maximum height, how much net force is acting on the body? Net force of magnitude and direction, because force is the vector quantity, so we should represent both magnitude and direction. So come to our question. See, mass they have given 0.1 kg. The question is, if the body is projected upwards, here A, B, C, three questions are there. A, B, C, three questions are there. First one is, when the body is projected upwards, what is the net force and direction on that? So whenever the body is going upwards, always you know that each and every body is attracting towards the center of the earth. That is nothing but weight of the body. And here you can say that gravitational force magnitude is how much? 0.1 into G value is 9.8 meter per second square. So 0.98 newtons. And you should give the direction, always it is acting downwards. When you can go through the B, it is coming vertically downwards. Even vertically downwards also, same magnitude is acting and same direction, it is acting towards the center of the earth. Even at maximum height also, we can observe the same answer, because always the weight of the body is acting towards the center of the earth. This value is 0.98 is the magnitude, that number, and the direction is towards the center of the earth, and you can say the downwards also. Then our second short answer question is, define momentum. What is the momentum? What is the impulse? And law of conservation of linear momentum along with examples. It's very important answer. What is the momentum? Simply you can say that product of mass and velocity. Product of mass and velocity is called the momentum. It's very easy when we can go through the concept wise. Quantity of motion is called the momentum. See, momentum equals to mass into velocity. Unit is kg meter per second. Unit is kg meters per second. Then impulse. Impulse is represented by J. You can write this is the force into time. Force into time is called the impulse, and you can observe the same unit, kg meter per second is the unit. Otherwise you can say impulse is a large force is acting in short interval of time. A ball is hit by the bat, in fraction of seconds large force is acting on that ball. So you can say that is also one of the example for impulse. Impulsive force you can define, product of force and time is called the impulse, and both are having the momentum and impulse, both are having the same unit. Then our third one is, this is the first bit, this is the second one. In that, what is the law of conservation of linear momentum? See, if there is no external force acting on the body, means force equals to 0. And from the Newton's second law, what is the formula for force? F equals to rate of change of momentum. But clearly they have given F equals to 0. D by dt of, instead of momentum we can write it mass into velocity. What is the meaning for this? This is 0 means it does not changing with respect to time. So mv equals to constant. mv equals to constant. So it should be right, m1 v1 equals to m2 v2 also. Look here, momentum definition is over, impulse is over. Law of conservation of linear momentum means if there is no external force acting on the body, means immediately you can say momentum is equals to constant. So we can write it m1 v1 equals to m2 v2. And you should give two examples also. One is the explosion of the bomb. One is the explosion of the bomb. What happens? Suppose the bomb is splitted into two parts. One part is coming this side, another part is going that side, because both are having the opposite direction. Then like that, gun and bullet is there. One bullet is going like this, but the gun is coming backward direction. Why? According to law of conservation of linear momentum. No need of giving that much explanation. Just you should give explosion of the bomb and bullet fired from the gun. These two examples you can take it. Then our third S.a.q is, why are shock absorbers used in vehicles? See, many people are giving the ads. Suppose they want to give one new motorcycle. They are riding on the mountains and they are riding on the uneven roads. What is the reason? They want to show that even they are traveling on the uneven road on mountains also, we feel same it is even road. Why? They are using the shock absorbers. Shock absorbers are like springs only. When we are pressing on that, look here, this is one shock absorbers. Whenever we are applying the force, then what happens? Here impulsive force is acting. That too force is inversely proportional to time. In this case, force is inversely proportional to time. When we are pressing on this, time is increasing. When time is increasing, automatically we can reduce the force. So whenever we are using the shock absorbers, we can increase the time, we can reduce the impulsive force. Then easily, nicely we can travel when the vehicles are having the shock absorbers. Not only this one, while catching the ball, always we can lower our hands towards ourselves. Why? We should increase the time, then we won't get any hurt. Suppose our hands are like that towards the ball, so when at that time what happens, time is less, more hurt, more force is acting on that. So from this you should remember that whenever we are increasing the time, when we fall on the sand and cement road, where we will get the more hurt, cement road. When we are falling on the sand, slowly we are going, time is increases. So when the time is increases, you can reduce the force, not only in shock absorbers, not only in the case of what is that, while catching the ball, in all that many applications are there based on the impulse. So anyway, our question is, what are the, why we are using the shock absorber means we can reduce the net impulsive force on that. Then fourth question is, explain the limiting friction, dynamic friction and rolling friction. See, one friction only we are having the doubt, means how we should learn these, means don't confuse. Whenever the body is at rest condition, that is called the which friction? Static friction. Static friction. Then whenever the body is having the moving condition, sliding, not moving, so sliding means that is the dynamic friction. When the body is rolling on the surface, like vehicle tires are rolling, no, that is at that time which friction is acting? Rolling friction is acting. But the question is here, limiting friction. Maximum of static friction is called the limiting friction. Suppose horse cart is there. Initially we are applying the more force. Why? We should overcome the limiting friction. Look this graph, easily you can understand. See, we are applying the force on the x-axis and this is the friction. When we are applying the force like 1 Newton, 3 Newton, like that, along with this force, friction is also increases, it reaches to the maximum. Look here. From here to here, the body is at rest condition only. But maximum of limiting friction is called the limiting friction. Then immediately, slightly, even after 10 Newton, slightly it is decreasing and it is moving like this. So from this, what you are understanding? See, maximum of static friction is called the limiting friction. When the body is sliding on the surface, that is called the dynamic friction. And dynamic friction always less than the limiting friction. Then last one, you know that what is when the body is rolling on the surface, which friction is acting? Rolling friction is acting. Then fifth question is, what are the advantages and disadvantages of the friction? See, without friction, we can't survive also. Why? We are walking on the earth, we are walking on the road without slipping, means because of the friction. Friction is a self-adjusting force. When we are going forward direction, it is acting backward direction. We can able to apply the brakes in the vehicles because of the friction only. We can hold the marker because of the friction between these fingers and this. We can drink one glass of water, so that is the because of the friction. We can use the nails to attach this one, that is also because of the friction. So we can drink a glass of water, between the glass and that one, friction is acting. So all this, we can apply the brakes, we can walk safely, and we can driven that nails, and all belongs to the advantages of the friction. Then one more thing in this, what are the disadvantages of the friction? See, factories are continuously running. Not only factories, fans are there, continuously running. When we touch that one, what happens? We feel some heat. So their electric current is doing mechanical work. Because of the friction, heat is developed. Not only in the case of any electronic device, heat is produced because of the friction. That is the wastage of the power that is due to the friction. But and not only this one, when we are running machinery system, wear and tear of machinery system is increases. Some cracks we are observing, that is called the wear and tear. These two are the disadvantages of the friction. Then our sixth short answer is very easy and interesting also. Mention methods of reducing friction. How many methods are there to reduce the friction? There are 4 methods to reduce the friction. For reducing the friction, there are 4 methods. First one is the polishing the surfaces. Polishing the surface. See, this is one surface. When we are polishing, what happens? We can use like this. Then what happens? We can reduce the friction. Then second one is the using lubricants. Lubricants means grease, oil, soap, water, and like this one. See, this is one uneven road. Whenever that grease or soap water is there, what happens? It forms the thin layer. Then uneven elevations and depressions are closed. Then we can reduce the friction. So just now I said in machinery system, wear and tear of that one is increases during the friction. So for that reducing friction, they are using grease and some oils. Even our bikes also some oils are there. Why? To reduce the friction. Those are nothing but lubricants. Then third one is the ball bearings. Ball bearings. These days modular kitchen and in our bikes also ball bearings are there, like round balls are there. Those are also used for to reduce the friction. Especially in this case, sliding is there. No, sliding is a dynamic friction. Rolling is the rolling friction, which is less rolling friction. So automatically you can convert from dynamic to rolling. Which one we are using? We are using the ball bearings to reduce from dynamic to rolling friction, because rolling friction is less than the dynamic friction. Then fourth one is the streamlining. Streamlining. Streamlining means automobiles and aeroplanes are specially designed to reduce the air friction. See, air is also opposing your motion. Suppose you are taking cars, that design is different. Bus, that is different. That bike, that is different. Aeroplanes, in air they are traveling like bird only. Why? To reduce the friction. Simply you can mention that to reduce the air friction. Automobiles and aeroplanes are specially designed, that is called the streamlining. What is the use of this streamlining? Means it is reducing the air friction. So our sixth short answer is also over. Then very important next one. Why pulling the lawn roller is preferred than pushing the lawn roller? Why pulling the lawn roller is preferred than pushing the lawn roller? It is also very important. One side I am taking pulling the lawn roller. Another side I am taking pushing the lawn roller. Pushing the lawn roller. Look here. So in both the cases, we are taking, this is the lawn roller. Where we are placing on the surface. And here also we are taking one lawn roller. We are placing on the surface. Then how many forces are acting on that? Just now you know that always weight of the body is acting downwards. For every action there is an equal and opposite reaction. That is normal to the surface means we can call normal reaction. In both the cases weight is acting downwards and this normal reaction is acting upwards. But what is the difference between pulling and pushing? Look here. Pulling means we can apply the force like this. Pushing means we can apply the force like this. Many people are confusing. Pulling, just you take the thread and you should pull like this. Then it will make how much angle with horizontal? Theta. Pushing means it is also pushing like this, and here also it is making how much angle? Theta. But the difference is it is the positive x-axis, but it is with in between the x and negative y-axis. Look here. F is resolved into two components. This is F cos theta and this is F sin theta. And here also f is resolved into two components. One is the f cos theta, but f sin theta you can observe it is acting downwards. The only difference is this only. So diagrams are must for this one. Now you look here, come to pulling. On this, how many forces are acting vertically? Vertically 2 are acting upwards. So n plus f sin theta equals to mg. From this mg, n equals to mg minus f sin theta. But where is the friction? See, friction is a self-adjusting force. If the force is acting right hand side, it is acting left hand side. Fr equals to, what is the formula? Mu r into n. Mu r is the coefficient of rolling friction. So Fr equals to, we are writing mu r into, instead of n, mg minus f sin theta. See, this is very important point. From this only we will give the conclusion. Then come to pushing side. So here also only one force is acting upward, that is the normal reaction. So we can write it n equals to mg plus f sin theta. Where is the rolling friction? Here it is like this. So Fr equals to, what is the formula? Mu r into n. Then Fr equals to mu r into, instead of n we are writing mu r into, mg plus f sin theta. Now you see, this is equation number 2. Which friction is more? Pushing, here plus is there. Pulling, here minus is there. Here minus is there. So which friction is more? Pushing friction is there. More friction means it's very difficult to move. So that's why we are preferring the pulling comparing with the pushing. Only from equations 1 and 2 only we can say that the friction is more in the case of pushing comparing with the pulling. Then our last short answer question is about the rolling friction. The question is, state the laws of rolling friction. See, rolling means, just now we discussed, this is the rolling. If the area of contact is less, that rolling friction is less. If the area of contact is more like this, that friction is more. Then that too you can say this rolling friction is directly proportional to the normal reaction. Rolling friction is directly proportional to the normal reaction. Here you are getting one constant mu r into n. Here mu r is called the coefficient of rolling friction. Once again I am repeating, if less area of contact, less rolling friction. If more area of contact, more rolling friction is there. And what is the relation between friction and normal reaction? See, both are directly proportional to each other. Here you are getting one constant, that is called the coefficient of rolling friction, that is represented by mu r. So mu r equals to, we can write it Fr by nRC. This is the constant. Mu r equals to Fr by n. Thank you everyone. Please subscribe my channel.